Sometimes we actually want to manipulate or change the brightness values of individual pixels in order to better show what we're trying to show in an image. And when we do this type of thing, we call it spatial filtering. Any sort of spatial filtering is going to involve some sort of convolution kernel. And I'll talk about what that is in just a second. But the three primary types of filters that are out there are ones called low-pass filters, which tend to smooth things out, high-pass filters, which tend to accentuate things that are different than their surroundings, and edge enhancement filters that tend to accentuate things that are lined up in a preferential direction. So let's start by talking about the convolution kernel. The convolution kernel is typically a small grid such as this, sometimes 3 by 3, sometimes 5 by 5, and each one of these pixels would have a value associated with it. These values are typically going to be multipliers, and what this small little window is going to do is it's going to move across the entire remote sensing image and apply some sort of convolution, some sort of mathematical formula to each central grid cell and change it according to some category or to some requirement. So here's an example here. This would be a low pass filter, and it's using the kernel that we just talked about. Each one of these values is a 1. So if we start with, this would be part of a much bigger image, but we're just going to show how this convolution kernel sits over one small 3 by 3 number of pixels in that much larger image. And the values of those pixels before the convolution kernel, or before the filtering, are 2, 1, 200, 1, 100, 150, 100, 150, and 25. When we apply this filter here, we put this value over top of this, and then we multiply each one of those by 1. We add them all up, and then we divide by 9 because 9 is the number of pixels. So we do include that central pixel, but that's going to be, in the end, the only one that has its value changed. So we can see here we've got this, if we add up all of those after we apply, we're going to get 729. We divide that by 9 and we get a value of 81. And that value of 81 is going to be reassigned to this pixel here. That's this pixel here shown in blue. Then this window moves over 1. And it finds out and it does that same sort of filtering on this one, and then to this one, and then to this one, and then to this one, until it's run through the entire remote sensing image. So if we apply a low pass filter, the things that are a little bit higher than their surroundings are going to be bumped down, the things that are a little bit lower are going to be bumped up, and we end up with a smoother image. As we can see, this has had a low pass filter applied to it. Some of the pixelation here is quite obvious, and it's a little less obvious over here because everything's just been smoothed out a bit as far as its brightness value goes. And of course, in this case, since it's a color image, the brightness value would be, this filter would be applied to all 3 of the bands that are making up this color image here. So things have really gotten smoothed out, and now we're kind of seeing a smoother representation of what this looks like. So that would be what a low-pass filter does. It kind of smooths everything out. A high-pass filter, on the other hand, tries to accentuate the things that are different than its surroundings. So in this example here, we can see that now these values have changed. Most of them are a -1, with the exception of that central value. It's a positive 16. So anything that's a little bit different is going to really be accentuated by this high-pass filter. In this example here, all of the values of the surrounding pixels are 50, and then there's something that's just a little bit higher in the middle. It's 75. But what we can see is after we apply this low-pass filter, we get a lot of -50s here, and then associated with this one in the middle, we would get 75 times 16, or 1,200. And then once we do the math here, we would get a value of 800. We would divide that not by 9 this time, but just by 8. And in this case, get a value of 100 for the middle. So this middle pixel has gotten bumped up a little because it's so much different than its surrounding pixels. And that's the idea of a high-pass filter, is trying to accentuate what's different than the surroundings. And this would be an example here where we start over here with the original image, and then we apply this high-pass filter. We can see, especially in areas such as here, we might be able to make out a little more detail now as far as what the linear trends are in this area here, maybe also in this area here, because we've applied this high pass filter to it. So the high pass filter can bring out additional detail in your imagery, but if you have noise in your imagery, it can also bring out that additional noise. In this case here, I think it's actually bringing out information as opposed to noise. Another type of filter we can apply is an edge enhancement filter. And in this case here, this would be an edge enhancement filter if we were trying to bring out features that have a north-south trend. And this would be a kernel for an edge enhancement filter if we were trying to bring out features that have an east-west trend. Or we could have a diagonal for northeast or southwest type trends. So we can design any sort of convolution kernel we want to in order to filter our data. This just happens to bring out edges a little bit better. And we can see that with this edge enhancement filter here, we're bringing out the edges a little better. The edge of the water here and where the shadows are looks better resolved in this image here. And some of the other linear features, such as some of the patterns in the grass here, look better resolved as well. So these edge enhancement filters can bring out those subtleties, especially associated with things where there's a rapid change in brightness along any sort of edge.